A very pleasant afternoon to all. I'm Hemashri, Meeting Committee Head of ASC SVC Student Chapter. I would like to take the immense pleasure to extend a very warm welcome to all the students and faculty of Civil Engineering Department, Sri Vidyaniketan Engineering College, on behalf of ASC SVC Student Chapter. Today, we have gathered here for the guest lecture on role of foundation technologies in the infrastructure development of India by Dr. K.S. Ramakrishna, Senior Geotechnical Consultant, Chairman-DFI of India, Member Board of Trustees, DFI USA. I would like to request Faculty Advisor of ASC SVC Student Chapter, BOS Chairman, Head of the Civil Engineering Department, Dr. O. Ishwar Reddy sir, to address the gathering. Please, sir.
Thank you, ma. So, good evening, sir. Dr. K.S. Ramakrishna garu.
Good evening, Andy.
Good evening, other colleagues and my students.
Sir, good evening, sir.
It's very nice to see Dr. K.S. Ramakrishna garu on this evening. So, to deliver a lecture on role of foundation technologies in the infrastructure development of India. He is renowned geotechnical engineer, so who has practiced in all frontiers of geotechnical engineering. So he held different positions in the industry, so in different companies, especially L&T has contributed a lot to the field of geotechnical engineering. Now he is, after post-retirement, is contributing so more to the development of foundation engineering, especially through DFI, so Deep Foundation Institute of India. So it's our privilege to have Dr. K.S. Ramakrishna to deliver it on, so especially how the foundation technologies are very, very important for the infrastructure development in India. So I am very happy to welcome Dr. K.S. Ramakrishna garu. So fortunately, he is a student of my professor, my guide, Professor M.R. Madhav. So I welcome you, sir. Thank you very much, sir. Sir, మీరు unmute చేసుకోండి, sir.
Yes, thank you, Professor Ishwar Reddy garu and Hemashri for your introductory remarks, and good afternoon to all the
Sir, 1 minute.
participants in this online program.
1 minute. She will introduce.
Yeah.
Go ahead, Hemashri.
Yes, sir.
Go ahead with my.
Thank you. Now, Yashashwini, corresponding secretary of ASC SVC Student Chapter, will take the opportunity to read the profile of Dr. K.S. Ramakrishna, sir. Please, Yashashwini.
Thank you, Hema. It is my pleasure to read the profile of Dr. K.S. Ramakrishna, sir. Dr. K.S. Ramakrishna is a geotechnical engineer with more than 40 years of experience in a wide spectrum of geotechnical and foundation engineering projects, right from the design to construction for land, nearshore and offshore projects. He is a member of the board of trustees of Deep Foundation Institute, USA. He is also the founder member and currently the chairman of Deep Foundation Institute of India, a non-profit organization established in the year 2013, registered with Ministry of Corporate Affairs and affiliated to the DFI USA. As head of foundation engineering in Larsen and Turbo Limited between 2005 and 2013, he was responsible for giving technical expertise to various projects and companies within L&T. He was instrumental in identifying and implementing several latest foundation technologies, equipment, and in building competency in special foundations. This has culminated in setting up a specialist foundation company by L&T by name L&T Geostructure, and Dr. Ramakrishna played a key role in establishing the same. He retired from the L&T as Chief Engineer, Technologies in 2013. Prior to the above, he held senior management position in specialist foundation companies in Singapore, Soilcrete Private Limited and Econ International Limited. Responsible for business and execution of projects in soil improvement, geotextiles, deep foundations, and marine structures. He was deputed to India as Director of Econ India Private Limited from 1997 to 2001. Between 2001 and 2004, he set up and managed his own company to bring technologies and equipment to benefit India's infrastructure construction. Before going abroad in 1990, he was with Engineers India Limited as geotechnical design engineer at New Delhi for 10 years and was responsible for design and construction of geotechnical and foundation engineering works for projects in hydrocarbon and non-ferrous metallurgy industries and offshore oil and gas platforms, and for establishing feasibility of underground storage of hydrocarbons in rock caverns. Dr. Ramakrishna has a number of technical publications. He has delivered lectures on special foundation and ground implement topics at various forums in India and abroad. He received his bachelor degree in civil engineering from Government College of Engineering, Kakinada, Andhra Pradesh, India in 1974, and master and doctoral degrees from the Indian Institute of Technology, Kanpur in 1976 and 1980 respectively. Dr. Ramakrishna received DFI President Award in 2017. He is conferred the highest award to individual, Distinguished Service Award by DFI USA for the year 2020. Currently, he is offering independent consultancy services in foundation engineering and in project implementation for land, coastal projects, and offshore oil and gas projects. Now, I'd like to invite today's guest speaker to start the session. Please, sir.
Thank you, Yashashwini, for the kind words. Let me start this program, my lecture, by thanking Professor Ishwar Reddy Garu, Professor Purushottam Garu, and other faculty and management of Sri Vidya Niketan and the organizers of this ASCE student chapter. And without much ado, let me start the lecture.
Yes, sir.
And is it okay now? The screen is all right?
Yeah, sir, you can share, sir.
Is it okay?
Yes, sir.
Fine.
Yes, sir. Good.
Sir, unmute yourself, sir. Sir, unmute yourself.
Is it okay, sir, now?
Yeah, sir.
Fine, fine. And good afternoon and welcome to all the participants in today's program. And my sincere thanks to the Sri Vidya Niketan management and Professor Ishwar Reddy Garu and Purushottam Garu for giving me this opportunity today. And I'll start the lecture on the role of foundation technologies in the infrastructure development of India. Now, in this lecture, I shall discuss in a few steps what I want to convey about the topic. One is India's infrastructure development outlook. What is there on the plate for all the stakeholders of the construction industry in the world? The second one, the status of some of the projects under implementation in India, how they are performing, how is the implementation going on. The third is what is engineering and what is technology. And quite often we use these two words as one and the same, but from the project implementation point of view, I would like to bring some differences so that you will understand from that project context what these mean. And the next one is the role of foundations execution in a project. How important is to complete project foundations in time for the complete project. Then other one is various foundation technologies that are available. Some of them I have put some photographs, and if time permits, I will explain to you. The next one is some photographs of the foundation technologies and equipment. Then a brief summary of today's lecture. Now let us look at the India's infrastructure development outlook. What is there for all of us? And I recall with great respect one of our greatest engineers from India, Sir Mokshikundam Visvesvaraya, who lived for more than 100 years. His statement, which is very, very appropriate for all of us, is engineers must make it a point or a custom to discuss national affairs in relation to their profession. Most of us talk about politics. Most of about, of late in the last 7-8 months, we have been talking about COVID more than anything else. But what he meant is that we are in a profession of civil engineering, and how we relate ourselves to the nation, and what is that we can, from a civil engineer's point of view, how do we look at the affairs of the country? This great advice of our great civil engineer, I would start with this infrastructure sector in India. I have taken this very latest from India Brand Equity Foundation. This is the latest on India infrastructure. It is the key driver for the Indian economy. The infrastructure is the key driver of Indian economy. It's highly responsible for propelling India's overall development. If you develop infrastructure, your overall development also will take place. We have seen this when Golden Quadrilateral was completed, how the country had changed a lot. Then the government of India's intense focus on some projects, importantly the infrastructure projects, so that they are completed in time, in a time-bound manner, and in the process we will be able to create a world-class infrastructure. And government's policy support, there are several of them, but I've just picked up a couple of them. One is the housing for all. We are about 134 crores. Even 1/4 of that, if we make houses, I think houses will be, everybody will be housed. Another one is smart cities, and 100% foreign direct investment on automatic route across various infrastructure sectors. And these infrastructure projects include power, bridges, dams, roads, and urban infrastructure. In these areas, the government is said 100% foreign direct investment can be automatically brought in. And India requires about 50 trillion, about 7,777.7 billions of US dollars by 2022 to have sustainable development. Most important thing is getting money, and we should be able to spend it. This is where construction industry plays an important role. If you want to spend 50 crores in a month, you must have the right equipment and the people so that you can construct and get that kind of expenditure. Otherwise, money will be only in the bank and you will not be able to spend it. So you should have all the resources to spend so that you can construct the infrastructure. So simply getting $777 billion by 2022 doesn't help unless you have construction industry geared up for that. India is witnessing significant interest from international investors. I think one of the only countries in the world where people are looking to invest. India is expected to become world's third largest construction market by 2022. I hope this COVID factor is also considered in this, which I'm not very sure. And even after COVID, if we are going to become third largest construction market by 22, I think we'll be very lucky. Now, let us look at the ongoing projects and what is the status of these projects. What is because the government is directly monitoring them. This has been taken from Business Today as late as yesterday. My earlier thing, I came to your campus in 2013. That time, I think I was bringing some other figures, but this one is much more interesting. The Government of India is monitoring about 1,424 infrastructure projects, each of them more than 150 crores value. It's not a small money. Out of that, 344 projects are reporting cost overrun. That means their estimated cost is exceeded even before completion of the project. Then there is a 384 projects have undergone time escalation. Now, looking at this cost overruns, let us look at the figures of these 1,424 projects. Total original cost of implementation is 18.2 lakh crores. Anticipated completion cost is 21.34 crores. You can see the difference. Overall cost overrun is 3.16 lakh crores, which is about 17.4% over the estimated cost. This is as per the Ministry of Statistics and Program Implementation, December 2018. I think I'll do. I don't know how to reduce this screen, side screen here. Okay, now if that is as far as the cost overrun is concerned. Now let us look at the time overrun. Out of the 384 projects that have gone over estimated time, 113 projects have overall delay in the range of 1 to 12 months. 61 are in the 13 to 24 months. 101 projects are delayed by 25 to 60 months. 109 projects show more than 61 months and above. That means more than 5 years delay. Now, looking at, I don't know how to see this. The average delay of the projects is 44 months. That is almost 4 years. Can we believe? Can we afford this kind of delay, which is coming to a cost overrun of about 3.16 lakh crores? What are the reasons for this implementation delay and cost overrun? Now, delay in land acquisition is a common problem. Forest clearance, supplement of equipment, fund constraints. I think as civil engineers, we can't do much about this. But the other one I'm going to have highlighted with yellow, geological surprises, that is subsurface, the ground that is related to my field, that is geotechnical engineering, the geological surprises, geo-mining conditions. I really exactly don't know what exactly is it really mining or something else. And slow progress in civil works, that is connected to us as civil engineers, shortage of labor, inadequate mobilization by the contractor, that is also concerning our industry, construction industry. Others like Maoist problems, court cases, contractual issues, rights, so all those things are there. And at the end, I'm sorry, unfortunately, I'm not able to show this on the screen. I don't know where to put this. Now you see this, for many projects, the time and cost overrun figures are underreported. That means actual delay cost time more than what is shown here. I'm sorry, I'm not able to move this away from my screen.
What, sir?
No, bottom bar, this toolbar, I'm not able to move it out because some lines I'm not able to read. Okay, now what we should do as civil engineers, we must think on how to mitigate, how to reduce these problems being faced by our country in project implementation, particularly in those highlighted areas of geological conditions, labor availability, equipment availability, mobilization of resources by the contractors. These are the areas as civil engineers we must look at, and some of my slides will address them, and not directly but indirectly. You can see that and you can understand. Now, success of infrastructure project implementation depends, from my experience, is a good feasibility report normally the feasibility reports are also not done sincerely. They just put up some things and call it is a feasibility report, and which is not actually factual, but it is some sort of report which we cannot totally depend. And timely finance and investment. Committed and efficient project management is very, very important. Competent engineering. The engineering must be economical and buildable. Whatever is in the engineering done, that should be buildable. They should see what is available resources, manpower and equipment. Accordingly, they should do the designs. And appropriate technologies and equipment. Once you have these things in place, you will have safe, faster to build the projects, and you will have less manpower, less management at sites. That is what is called lean construction. Then you need to have experienced construction engineers. If 7 is skilled workforce. If most of the engineers are going away to IT fields, there will be very few left for construction and engineering design. So you need to have skilled workforce. This is a very serious problem being faced by the country. So even if you have 777 billion US dollars or 50 trillion Indian rupees available by 2022, with these problems of experienced in construction engineers, skilled workforce and equipment, if they are not there, we will not be able to use that money in time. So again, your projects get delayed, your infrastructure gets delayed. And briefly, what is engineering and what is technology from a project point of view? And if you must be, as students, you must be seeing some colleges are called colleges of engineering, some colleges are called colleges of technology, some of them are called colleges of engineering technology, and various definitions are there, various titles are there for engineering colleges. As a person who came from the projects and construction, I am talking only from the project point of view, and you understand this from this point of view as during my lecture. Here, engineering, according to me, is a design process. The process involves definition of facility. What is that you want? Whether you want a building or a road, seaport, airport, dam, industrial project, whatever. What is that you want to create? That is the facility definition. Second, that is normally done by the owner, the one like government or private bodies or individuals. These are the ones who will define this facility. Then, as civil engineers, we should have knowledge of strength and behavior of materials, which is normally taught in these colleges. Knowledge of loads, earthquake loads, wind loads, and external loads, dead loads of the buildings. All these knowledge of loads you should have. And once you have all these things, you must know how to put them together in the form of design steps and methods to produce the engineering output. Normally, what is the engineering output we come up with? One is we come up with drawings, plans, elevation, sections, sizes of various components. The second one is we write specifications. What should be the contractor doing to create that facility? What kind of things he should follow? What kind of materials he should use? What kind of equipment he should bring in? All these things are written in specifications. Third one is we estimate the quantities of work of various types and we make cost estimates. So this process is called engineering, which is normally done in the office. So this is what I am calling engineering. The next one is technology. Technology, you can take this as a process that is responsible for making the facility, whether it's a building or road. That is technology. That's mostly related to activities before and during construction. Technology process involves construction planning, method of construction, quality assurance and quality control documents, selection and finalization of plant, equipment and tools, selection of manpower based on skills required, site organization, setting up plant and equipment, actual construction. Then what is that output? Output is basically in the three categories. The first one is the facility that you have created. End of this construction, you see the facility created. But then, have you done it in time and within the cost? That is the most important thing. If you have not done these two things within the cost and within the time, you know that you have not done a proper job. Although the building may look beautiful, but you have lost a lot of time and you have exceeded the cost estimated in the beginning. So project is in trouble. Now let's go to the technology. As you know, is the engine of growth. Just engineering doesn't help unless it is backed by technology. What I shown you as what I meant by technology, you will not be able to complete the construction of facility. So therefore, for any growth, the technology becomes the engine. You see what has happened. This is one I have taken from Center of Politics, March 15, 2019. You can see in the last 50, this is a acceleration of technology with the time, starting from 1400 to 2050. The last, you see, initially it has gone slow. All those things, telescopes and the printing press, telephone, electric bulb, and all that, rockets. But of late, in the last 50 years, the technology has gone exponentially, starting from rockets to the artificial intelligence, mobile phones, internet, and all these things, all these things are happened in the last, maybe last 15, 25, 30 years. It is an exponential growth of technology. Unless you are abreast of these technologies, you will not be able to ensure growth at a rapid pace. Now coming to the foundations, what is the role of foundations in the project implementation? Foundations in a project normally, when you look at the project cost estimations, the foundation cost of a total project comes to 1 to 5% for an industrial project. Supposing if it is a bridge project, bridge on river or offshore platforms, jetties, bridges, all these things normally almost close to 50% of the project cost, they will be the foundation cost. All normal industrial projects, the foundation cost will be about 1 to 5%. So it looks like a very small percentage of the total project cost. So because of this, the owners and project implementing authorities, they do not really put some sufficient attention to this foundation. They just call some subcontractor, whether he knows the job or not, he will give the job to them, and the job will not be executed in time and properly. Now, what happens? The project starts, they bring some contractors, subcontractors, and foundation contractor, and ask him to start the job. He will not have the right knowledge, will not have the right equipment, right people. So the project gets delayed. And in a project of, let us say, 40 to 50 months, first 6 months, people may not really bother about the delays. Whereas normally a typical foundation construction time will be maybe 3 to 9 months, less than 1 year. So this time, most of the time is lost because of poor selection of the subcontractor, the methods, the equipment, and the labor. Now, by the time they realize this, the project is already delayed by at least by 6 to 9 months. That will go on getting accumulated, and the entire project gets into trouble. So, unless the foundations are done properly and in time, the entire project because without foundation you cannot do anything. First thing is the foundation. It has to be done in time. If it is not done in time, the entire project is delayed. There's no way you can recover. Now, one project I was involved in the eastern part of our country, where we were setting up a steel plant. The client had selected a type of foundation, clients consultant, and they wanted board cast-in-situ piles. And we got the job, the total job we got, and that time when I went to site and we had seen, and we told them that this is not the right type of foundation. And then I requested, we did some demonstration of a new technology. We spent our own money and told them better you adopt this. But because of our contractual procedures, they said we can't change the contract now. So as a result, this project got delayed by more than 1 year and resulted in a cost escalation of more than 2,000 crores. And these are not my figures. The CEO of this company, the steel company, the owner of the company, or the CEO of the company, he published this in the newspaper. 3 million ton per annum expansion project of a steel manufacturing company, resulting in a 2,000 crores cost overrun and 1 year time delay. So this is whose money is this? Is the public money, and we have put them down the drain just because of delay in foundation works. Selection of foundation was not correct, and the whole project went to a disaster. Now, as you know, if every structure requires a foundation, foundation is the first step. First step, I mean, not site clearance and survey and things like that. First actual construction, first step in construction is foundations. Quite often, foundation construction takes longer than planned time. Result is the first step goes in the wrong direction, throwing out of gear the entire project and time cost. So as civil engineers, what we need to do, how we should do is, we should pay due attention to sufficient and good quality soil investigation and selection of right type of foundation and latest and appropriate technologies, equipment, method. And 4 is experienced and skilled manpower. Unfortunately, these 3 and 4, most of the construction engineers are not familiar with. In foundation technologies, what is the latest that is happening in the world? And if they themselves don't know, you can imagine they will, where from the skilled manpower and skilled engineer come. So these 3 and 4 are the most important part of a foundation construction. Soil investigation, and that we are trying to do from the Deep Foundation Institute. We are trying to improve the quality of soil investigation by training people, laboratory technicians and field operators. And the most commonly encountered challenge in a project is quality of soil investigation and report. This is generally, people gloss over this, they don't announce this. They normally, with the poor quality soil investigation report, the design is done. Numerous projects of national importance suffer their delay and cost overrun on account of poor soil investigation. I have shown one flow chart how a poor soil investigation will result in various problems, right from the bad design, bad tender document, during construction problems, project delays, then contractor claims and legal battles, and the cost overruns. I don't want to spend more time on this because we'll not be able to complete this lecture. So this given with sufficient detail, you can go through it after the lecture. Now, a second point I said in the thing is selection of the right type of foundation. I'll just give you a small flow chart how you should proceed in selecting the type of foundation. This I'll spend a couple of minutes. One is, first you get the good soil investigation done and get a good soil report. Engage a soil consultant, geotechnical consultant who is knowledgeable, and let him study the soil data. Let him study the loads that are coming onto the soil. And what is the performance criteria, whether it is structure is sensitive to the settlements, whether it's an earthquake zone, or whether it is a cyclone prone area. All these aspects should be studied. And what is the cost, time, and project schedule. If all these things are considered, his first choice should be shallow foundations. Shallow foundation mean particularly even in your Tirupati, soils must be very good. You can just make an open excavation and make an isolated foundation, or a mat foundation, or a combined foundation. All are on shallow depths. These are called shallow depths. Normally they are cheap. If it is possible, the soils allow you to do this. This is our first choice. We should not jump to pile foundations, even if the structure is very important. And one example is Delhi Airport. When we first thought Delhi Airport being such an important thing, we thought piling may be required. But when we go through all this step one, the entire airport was done only on shallow open foundations. So we saved enormous time and cost. So if this possible, go to shallow foundation, the project most probably will be completed within time and within cost. Supposing that shallow foundation is not good and the soil is not good, it cannot take the loads are heavy, or the area is critical, then next cheaper method is to look for soil improvement. Soil improvement is next cheaper thing compared to shallow foundations. And when you come across soils, you basically broadly can see the soils as cohesive soils like clays and silty clays, cohesionless soils like sands, gravels. These are cohesionless soils. So there are several technologies, and some of them I have given here. This list of technologies is not exhaustive. There are so many of them, more than 40, 50 technologies are available. Only I mentioned about 10 or 15 here. So you should explore all these things and then look for soil improvement as a second alternative to shallow foundations. Now, option one, I'll show these things when I'm showing you some photographs. I'll explain to them. Now, if the shallow foundations are not acceptable, soil improvement is not acceptable because the structure loads are very heavy and they are very critical. They are sensitive to settlements. You have to look for other deep foundations. These are called deep foundations. Driven precast hollow spun concrete piles. These are the cheaper. Next cheaper one is driven precast hollow spun concrete piles. Then driven cast-in-situ piles. Each of them, their method is different, the material is different, the process of making them is different, the testing is different. So many differences are there in this. Driven precast hollow spun concrete piles. This is the cheapest form of pile. Other than timber piles, nobody is using these days for important structures. So driven precast hollow spun concrete piles. We as from L&T we have done in Dahej, we have done in Kakinada. Option 2 is driven cast-in-situ pile. That is the next cheaper one. The third one is driven precast piles. This we have done in Kakinada, about 1.5 million meters of piles. We have done about more than 40,000 piles. We have done in Kakinada for 2 gas terminals, one by Reliance, one by the Gujarat Petroleum Corporation. Other one is CFA piles. I'll explain to you what it is. Continuous flight auger piles. From Deep Foundation Institute, we have tried to bring this technology. We have already done some demonstration, spending 80 lakhs, and we created a manual. Now we have approached the IS Bureau of Indian Standards to make it as a code. This is the next cheaper one. The last one among piles is board cast-in-situ piles. They are very expensive. Unfortunately, in our country, this is the most common pile. Deep foundation is board cast-in-situ pile. Unfortunately, that is one of the most expensive piles. Very unfortunate. We have got into the most unfortunately a most expensive type of pile. I have given what should be prerequisite for a good foundation. I am not going to spend time on this because this takes at least 10 minutes to explain, but I think I have put them in a right order, in a more detail. You can go through this. Like a design engineer, what he should know, construction engineer, what he should know, site operators and frontline supervisors, what they should know, what all aspects of this project they should know. All those things I have put them here. Kindly go through them. Most of the time, the one that I have shown in brown, people are supposed to know that they don't know. So you can imagine how a foundation construction will become one of the most often frequent reasons for project infrastructure project delay. Challenges being faced by Indian foundation industry, vastness of our country, diverse soils, geotechnical conditions are very different. Our economy, if it improves, then we don't have the manpower and equipment resources to actually construct things in time because we will be short of resources. We have got poor infrastructure. Some of the equipment cannot reach the sites. Low technology and low mechanization. We have only recently started mechanizing. Out of 45, 50 technologies, some 2-3 technologies are used in India. Rest of them are not being used. Geotechnical knowledge is confined to the academic institutions. Most of our academic professors, they all are very good and they have got the up-to-date knowledge of geotechnical engineering. But when you go to the practice, when you go to the construction industry, very few people are exposed, and most of the geotechnical engineers are not in the construction sites or in the design offices. They are all, most of them are in the academic institution teaching. The importance of geotechnical engineer in design and construction is not widely recognized in India. Whereas if you go abroad, even if you go to Dubai or you go to Singapore, you will find that geotechnical engineering is given a very good importance. General reluctance to encourage new technologies. We are somehow averse. We are not interested in bringing new technologies. Even the technologies abroad are 40, 50 years old. We are not willing to bring them. We bring and use only the grandmother time technologies. Site supervisors' exposure to foundation technologies is very low. So we thought these are all the challenges are being faced by the foundation industry. That's why in 2000, from 2010 to 2012, we tried to establish a Deep Foundation Institute in India. And the last 9-10 years, we have done a lot of conferences, seminars. Then we have done one technology implementation. We did a manual. Now we are going to make it as a IS code. So these are all the things as a Deep Foundation Institute we are doing to help the country. So what are all the various foundation technologies? Let us look at that. Now, foundation construction is highly equipment dependent. Unlike other civil construction areas, foundation construction is almost 95% dependent on latest equipment. And unfortunately, in our country, we do not have this equipment. Most of the equipments are imported. Not a single equipment is manufactured in India. I think it's our Prime Minister's Make in India policy. I hope somebody will start making it. Whereas China has been making most of the equipment for what is required for themselves, and they are exporting them. So unless this equipment is manufactured in India, we will not be able to do it. Now, first thing, as I mentioned to you, shallow foundations. They have various technologies. Then second one is deep foundations, which I mentioned to you already in the flow chart. One is board cast-in-situ piles, CFA piles, driven cast-in-situ piles, hollow spun concrete piles, steel tubular piles, and several of them. I have mentioned only 6. Now coming to soil improvement and soil modification, vibrocompaction, stone columns, lime and cement columns, prefabricated vertical band drains and surcharge preloading, vacuum consolidation, deep soil mixing, gutter soil mixing, jet grouting. These are only a few technologies. There is many more technologies. Then excavation support systems, diaphragm walls, contiguous piles, secant piles, Berlin walls, steel sheet piles, These are all used in our metro construction, underground station construction, whereas also in our coastal projects like jetties, wharves, port structures. Slope and embankment stabilization using soil nails, largely used in Bangalore and other places. Gabions at the river fronts and all that, we use gabions. Anchors, we use it in several places in excavation support as well as slope stabilization. Geotextiles, we use in embankment stabilization. Reinforced earth structures, you must be seeing bridge approaches and all that are done reinforced earth structures. Then dam cutoff walls using plastic concrete cutoff walls and other physical barriers. These are only some of them. As I mentioned to you, there are more than 45-50 technologies. I just only listed about 25 of them. And these are all the technologies that are available. And each of these technologies are developed by mostly the manufacturers of equipment along with the contractors. And so their technologies with them, equipment, tools, all these things are that is a different knowledge domain, which normally is not covered in college education. Now I'll just go through quickly some of these photographs. Board cast-in-situ pile installation sequence is a large diameter piles. What they do, this is a piling rig. This cost from between 3 to 20 crores each equipment, because depending on its capacity, the cost of the equipment is about 3 to lowest is about 3 crores and highest will be around 15 to 20 crores. So if you want to do large diameter, very deep piles, you have to have that kind of an equipment. And we have got a few companies like L&T, Afcon, Cementation, Keller. These companies have got a good number of equipment, Simplex. Here, what we do is we do a temporary casing to stabilize the soil. Then we start digging the soil using this equipment. This is called boring tool. This is called Kelly bar, and this is connected to this. This is called Kelly bar. This is called boring tool, and this is here you have got winches and drive motors. This goes through and drills the hole. We use a liquid called bentonite or a polymer to stabilize the walls of this borehole so that it doesn't collapse. Use that fluid, and once we reach the required depth of the boring, then we install the reinforcement cage. Then we pour concrete by a method called tremie concreting method. There is like a long funnel is put, and there concrete is delivered at the bottom. From bottom up, the concrete is brought up, and pile is completed. This is how boring is constructed. A lot of issues come in during this if the contractors are not quality conscious. Each board pile is a pain. You will not be sure of the quality of the construction, and it leads to a lot of problems. You may not be able to take the loads. But unfortunately, this is the most common, but is one of the most expensive ones in the country. This is another one is driven cast-in-situ piles. This is also very common in India after board piles. Here, first we drive a steel casing tube to the required depth with a bottom plate which is sacrificed. We leave the bottom plate in the ground, and then we use a hydraulic hammer from a powerful what is called pile driving rig. We drive this tube, and that once it goes to the required depth, we put reinforcement cage, and then we put concrete using what is this red one called skip. Concrete skip. We use this and pour concrete from top, and the whole borehole will be dry. Unlike in board pile where you have got bentonite or polymer, here it is a dry hole with bottom closed. You put concrete, and using the same hammer, slowly tap the tube and remove it. So leaving the concrete and reinforcement in the ground. That's how pile is made. It's one of the latest technology equipment which we brought in when I was in L&T. This is very high productive equipment, and we can do for projects much faster than when we use board piles. The other one is precast driven piles. These are expensive compared to other one, but if the size of the project is big, this can become very cheap. It's what we have demonstrated in Reliance Kakinada and several projects in Haldia, in near Calcutta. Many projects we have done in L&T using these equipment. We brought them from Singapore, and these equipment also use a hydraulic hammer and drive the already cast on ground precast piles, drive to the required depth. So every day you can do about 400 meters, almost 20-25 piles per day per one rig you can do. Whereas board cast-in-situ piling rig, each piling rig can do only 3 or 4 piles per day. Here you can do almost 20 piles with one machine. So that is the kind of speed you can finish this job. The kind of job we did for our Reliance Kakinada 6 months ahead of schedule. About 21,000 piles we have done. The other one is continuous flight auger pile. This is CFA pile. This is a technology which is more than 30 years old abroad. But unfortunately, so far, nobody is trying this in India. So what we did was, using Deep Foundation Institute as a platform, we went to the industry, requested them to donate. We brought about 70-80 lakhs in both cash and kind. We requested a foreign contractor, foreign manufacturer to bring his equipment, and we installed 6 piles and tested them, then made a manual. That manual is going to become a code soon. Here, the piling rig will have a long continuous auger. This is like a screw. This drives into the string, and this one will have a central hollow stem. And after it reaches the required depth, we introduce concrete from here, from the top, and pour in through this central hole. It goes, and as it builds up, as it comes up, the concrete is poured inside, and the concrete is first. In a board pile, we first put reinforcement and then concrete. Here, we first put the concrete and then put reinforcement. There are some problems for doing this. Reinforcement case may not go, so your concrete has to have proper flow characteristics. Its slump and spread has to be proper. All these things we have written them in our manual. Using this is the same piling rig that is used for doing board piles. Small modifications we can use that, and whereas board pile only one rig can do some 3-4 piles. This can do about 15 to 20 piles per day. So you can accelerate your construction, and pile can become much cheaper. This is a rig from the, you can see from close quarter. This is a kind of an auger. This is called continuous flight auger. This is driven down first, drilled down, and then concrete is introduced through this hose. This is called concrete hose, about 100 mm size, 4 inches size. And through that, concrete is pumped using a concrete ready mix will be there. Concrete pump will be there. It pumps into the hole here. Other one is, I mentioned to you hollow spun concrete pile. They are also very cheap. We have used it in L&T has done, AFCONS has done in some of the marine projects. Here it is a concrete is of very high grade up to 80 megapascals concrete strength, compressive strength pile. It is a hollow pile, so pile will not be like a solid pile like a precast solid pile or a board pile or a driven cast-in-situ pile. Here it is a hollow, like it looks like a pipe. What we use in pipe culverts. It looks very similar to that, but very high grade concrete. It can take a lot of compressive stresses. We use a hydraulic hammer, drive them to the required depth, and that's it. The job is done. In a few minutes, you can complete the pile. But it's very cheap. Of course, the other one is steel tubular piles. They are very expensive. Normally, we use them in offshore and marine jetties. As when I was in Engineers India Limited in the early 80s, we did a lot of offshore platforms using steel tubular piles. AFCONS has done in some of the jetties. L&T has been doing it. They use a special barge, and they are using it here. A hydraulic hammer of very high capacity because these piles will be 125 meter long. Go not 120 meters below the seabed, and another maybe 30 or 40 or 50 meters depending on water depth. The length of the pile will be at the order of 150 to 200 meters. All are done within a couple of hours. They drive them to the required depth. For offshore platforms, marine jetties, the steel tubular piles are used. Now, these are all what I mentioned to you, deep foundations. Sir, how much time I have? Hello.
Another 13 minutes, sir.
Okay. Because a few more slides are there. I'll go through.
No issue, sir.
Yeah. Now, I mentioned to you in the flow chart where we first should look at shallow foundations. If it is not done, we use ground improvement. If that is also not done, then you go for deep foundations. I just covered deep foundations. Actually, I should have covered soil improvement first, but deep foundations are more common. That's why I covered deep foundations. Soil improvement. If you look at any of these things, each of them use a different type of equipment that runs into crores. So we unfortunately do not have them in our country. We have to encourage people to buy them and bring them and use them. Now, soil improvement, one of the cheapest methods is using vertical drains, preloading, and surcharge. Number of projects we have done using this technology. And what is this purpose of this vertical drain? Normally, most of the time when you think of a drain, either it is horizontal or with a very slight slope, or mostly it is like that. You don't see normally a vertical drain. Here, the word vertical drain is a special name in the geotechnical engineering, where a manufactured material using polymer, geotextiles, we make vertical band drains, and using a special equipment, we insert them into the ground. And once it is installed into the ground, we apply load by putting some sand or other materials that are available, and we apply the load on the soil. Under that load, the water inside the soil comes through these vertical drains and escapes into the surroundings. So with the result, soil gets compressed and it will have the capacity to take higher loads. This is the purpose. In the process, what happens is, when you promote the use these vertical drains, the consolidation, some of you must have got exposed because some of you I understand are in the third year, some of you are in fifth year. I do not know how many of you are exposed to consolidation in soils. Consolidation is nothing but soil which has clay, which has got some water inside. If you throw away that water and soil particles come closer to each other, and they will have the capacity to take higher loads. That means bearing capacity increases and their settlements under load, actual loads will come down. So what we do is, whatever supposing if you don't do the soil improvement, you construct the building, and under the load of the building, there will be long-term settlements and there will be cracks in the building and the building becomes unserviceable. So what we do is, before constructing the building, whatever loads come on the soil, we try to put those loads using soil, sand, we preload it, and then once we do just like our pre-stressing, we do the preloading and use these vertical band drains and make all those soil to consolidate or settle under that load and remove that surcharge and then do the actual construction. So that's how we do this process of soil improvement using this technology. You can see here, this is if you see here, I have put a load in the top and settlement in the bottom. Suppose you load and the time, if you take here, this is the time when we start building the load. Our band drains, we install them and put this sand. It comes to some level, which is maybe 1.5 times or 2 times of the actual load. That's the final structure is going to impose on soil. And then under this load, the soil will settle like this. Now, after sufficient load is taken, this is the final settlement under load. So once we see the soil has settled that much, then we remove that soil and then construct the building. So this is how this principle of vertical band drains and surcharge. I really don't know how many of you are able to follow this, but probably if this is some of these fundamentals are covered in your course materials, this can be understood. This is that vertical band drain which I was mentioning. This is a geotextile, which is nothing like a filter cloth, and this is a PVC drain material, which is a corrugated material, which is like our corrugated sheets we use for sheet roof. Similar to shape, it will be. All these things will act as drain paths, and this acts like a filter. Only water will enter, soil will not enter, and the water comes out. This is the one that will be installing into the ground. This is what is called stitcher. Is a special equipment, and mostly this is an excavator or a crane based, and this is called stitcher. Just like your sewing machine, whatever a sewing machine does, this also does the same thing. The typical sewing machine, you at the bottom, there is a small hole through which you put a thread and then use that machine to pierce that cloth with that thread, and then how you do the stitching. Similar thing they will do with here. There will be a hollow stem, what is called mandrel, steel mandrel of a hollow cross sections, rectangular cross section, and through that vertical band drain material. This material comes in rolls. This is put into this. First, that mandrel with the band drain will go down, and once it reaches sufficient depth, then this mandrel, steel mandrel is withdrawn, leaving the band drain in the ground. Once all these band drains are installed, then they put the sand load, so that under that load, using these band drains, soil, water escapes and settlement takes place. Now, the other one is, those things are for normally this soil improvement technique is used for soft clayey soils and clayey silty clays. Here you have got granular soils, normally sands, gravels, and we have used this in some of our steel industry, where we have got man-made material, factory run material, what is called blast furnace slag. So those are also granular materials. You can use vibro compaction. Here, this is another big equipment used from the crane. This is called a vibrator. It is a vibrator. What do they call? Some of them call vibroflot. Some of them are called needle and things like that. They basically, there will be a horizontal. There will be a motor here which will be generating horizontal vibrations. So using this, we use the vibrator and water and create, supposing that this is all sandy area like our Rajasthan desert or Dubai or Middle East countries where you have got sand deposits. If you want to construct, first you have to do soil improvement using this technique. And millions of square meters of soil improvement is done both in Singapore and Middle East countries. Here, this one will be using water jet and vibration. This goes down to the required depth, and it starts generating vibration. So the soil starts collapsing, and then compaction takes place. And it's how a compacted column next to that another one is being done. So the whole thing gets compacted. Soil settlement takes place. Original ground will settle like this because the soil has gone and got compacted here. This is called vibro compaction. This is normally done in granular soil, sandy soils, or sandy silty sand areas. Other one is used for clayey soils using the same equipment called vibroflot. They use, what they do is they do granular pillars and granular columns they make inside the ground. They go to the required depth using these horizontal vibrations. Once they go to the required depth, they put the gravel, like our road metal, they put that, I mean, the size is about 4 inches down, they put it and they compact it, and end of it you will get columns like this. These are called stone columns or granular columns. This one will be, they will be able to take load. We have done this in early 80s, both in Madras refineries and Vizag refinery. We did an extensive job when I was an Engineers India Limited as a design engineer. But this is one of the extensively used because this is also first cheapest ground improvement is this. Sorry, this one vertical band range. Second one is this one. Using vibro replacement. This is called vibro replacement or stone column technique. Now coming to retaining structures. You know, embankments or sorry, these excavations we normally see whenever you see in cities when they are going to do car parks, basements, you will see the deep excavations are done. Or in the roadside, in the hills, when you cut the hill and construct a road, the slope may become unstable. In those areas, you need to retain that earth from falling down. So that is a thing. Various technologies are available. This is called Berlin wall. This is called contiguous board pile wall. This is contiguous board pile wall. This is secant pile wall. This is diaphragm wall with ground anchors. These are various. Each of them is a different technology. And this machine, which is doing ground anchor to give additional support. These are all ground anchors. This is a thing done with ground anchors. This is the Berlin wall. What they do is they'll do some pitch sections called soldier piles, and then they put timber planks one after the other, and then they make a wall with these support. These are going into the ground, and the lateral support is given by them, and this is how the earth is retained. This is one of the cheap methods. And this is a sheet pile wall. We drive sheet piles and then do the bracing. This is a sheet pile, well-constructed sheet pile wall. That is another sheet pile technology. We did about 7 webinars recently from the Deep Foundation Institute of India, DFI of India. Other things are secant pile walls, diaphragm walls, secant pile walls, Berlin walls, sheet pile walls. These are all these are various ways of retaining the earth. Each is a technology, different method, different process, and that's how it is done. In fact, at IIT Madras, I delivered around 12 lectures. Each of them one lecture, and about 12 technologies I have covered. Each lecture is about 45 minutes to 1 hour. And all those I condensed them today into a few slides. So you can imagine how difficult it is to cover and make you understand. But I'm just giving you an introduction so that you can go and read or see YouTube, find out, understand them. Kindly go through them. These are all interesting technologies. This is a secant pile walls with a bracing, steel bracings. The contiguous pile wall, contiguous pile wall with bracings. This is the soil nail wall. You commonly see them in hilly areas. If you Kanakdurga temple, if you have seen in Vijayawada, you will see that. Bangalore, you will see them. I don't know Tirupati. Tirupati also you have similar soils, but I don't know the soil nailing. They put soil nails into that and then put a goniting here with a wire mesh, so to stabilize the soil. And these are latest technologies. This is called soil mix retaining wall. This is called cutter mix walls. And these are all deep mixing using various types of equipments. And they do this kind of using in situ, they mix soil with cement. See, earlier, these are all made of pure concrete and reinforcement. Here it is, it is soil mixed with cement. In situ, they mix the soil with cement and make these walls because they are very good for temporary constructions. And sometimes you can use them for permanent construction depending on the kind of lateral loads that come. And this is a completed diaphragm wall with ground anchors at 3 rows of ground anchors. Each is a technology. It takes some time for me to explain to you, but I'll show you some of those equipment used for making this diaphragm walls. The wall, it is a reinforced wall, which is between 600 mm to 1 meter or 1.2 meter thick, depending on the lateral loads and the depth. Is how they construct in small rectangular panels. Contiguously, they do it. Other one is sheet piles. As I mentioned to you, we did about 7 or 8 webinars. With some experts gave a lecture recently. And these are the sheet steel piles. ArcelorMittal is one of the manufacturers who are supplying this in India. Abroad, they are very popular for water retaining structure, waterfront structures, and in pump pits in marine construction. And when we do in steel industry and for material handling, when we do in L&T, we did a number of projects for doing the conveyor systems, coal and iron ore material handling systems, where you do the wagon tippler and stack car holders. We use this kind of technology where these are all in sheet piles are all individual sheets of this shape or different shapes are there. They will be driven into the ground and one next to the other. And this portion is the interlocking portion. They get interlocked and preventing, they give lateral stability and prevent water from entering. And they are installed using an equipment called vibro hammer. As I mentioned to you, all foundation technologies are highly equipment oriented. So this is a PTC manufactured by PTC, is a vibro hammer. It generates vibrations by rotating two masses in eccentricity, and they produce vibration, and with that vibration they install them. This is a wall that is installed one next to the other. This is another type of vibro hammer which can be used from. This one is normally done from a crane. Crane is normally more expensive than excavator. This is called Movax excavator, an excavator-based thing with L&T Commerce we did in L&T in some of the projects. This is another technology we brought from Finland. You can see one of the L&T projects where we did in the river. In Madhya Pradesh, we did this project using the steel sheet piles. How each pile is driven and locked with the next one here. So this is actually around. This is around this all the river here, Narmada River, and this is they wanted to make a intake well here, water intake well for a thermal power plant. This is a well constructed braced sheet pile wall. Now, last one, I will come to dam cutoff wall. One of the technologies we brought from abroad in L&T. We did major projects using this equipment. This dam cutoff wall we did in Himalayas, and we did 97-meter dam cutoff wall in Bhutan. And when you construct a dam, even a Polavaram dam also we have done. My team has done. Of course, by the time I have retired, my team had done in Polavaram also. Yes, here, when you construct a dam, you will have on one side water is impounded or water is stored, and the other side, downstream side, it is water. There won't be any water. Now, what happens when you arrest the water like this? The water tries to go through this bottom and come to the outside here. And some of you in your irrigation class, you might have seepage and piping and all those things you might have studied. These are some of those things we use. Here, what we do is to prevent water coming out like this and destabilizing the dam, we do a wall here, a diaphragm wall, a 600 to 1200 or 1500 thick wall made of what is called plastic concrete. Plastic concrete is nothing but low strength concrete with high deformability. It is like a plastic. What children play, the clay, it looks like similar to that, about 4 megapascal to 6 megapascals compressive strength. We mix cement and bentonite in a proper proportion, and that we put into this Instead of putting concrete, we put plastic concrete. What will happen is, under the load of the dam settles, and this will not develop cracks because it is a plastic concrete. It will not develop cracks. If it is a normal concrete, under that kind of a load, when the deformations take place, then the concrete can crack and the water can go through. So we use plastic concrete. We have done major projects in near Simla and in Bhutan, and very successfully we have done using these latest technologies. And that equipment itself is 30 crores. Now, this is one side with cross section of the dam. If you look along this one river, this is one embankment, the left embankment, right embankment. This is how a finished cutoff wall looks like. These very vertical lines indicate the diaphragm wall, which is called plastic concrete cutoff wall. Then this one prevents it. Above this is the dam. These are the equipment. This is the equipment I was mentioning to you, is about 30 crores. That's called a trench cutter or hydrophrase. This one we use a very high capacity hydraulic crane, and this is about 12 to 13 meter height. There are bottom what we call cutter wheels. Depending, the different types of cutter wheels are used. This is called hydraulic grab or mechanical grab. This will grab the soil. You might have seen them in port areas and all. This is hard rock boulders. We break it using a heavy hammer, 15 tons to 20 tons weight. Each of them will drop them, and inside the ground we break the boulders and make the wall. So these are all the equipment we used in Himalayas to construct the dam cutoff wall. We did it very profitably and very fast, and we didn't have the technology with us. We didn't have the skilled people. We brought them from abroad, trained our people, and today in L&T we have a very, very strong team that can do it. We have bought one more equipment. We have got 2 of these things, and we use the several projects both in cities, diaphragm walls. Same equipment we use for making diaphragm walls, dam cutoff walls. Now, what I just want to tell our young civil engineers, that there are a lot of challenges, demands. With that, the civil engineering looks very interesting, particularly foundation engineering. We need to have a very good technical knowledge, and we need to update it continuously. And we must know the construction processes. We may not know the engineering. We may know the principles of mechanics, strength of materials, design processes, codes. All that is one part. The construction processes and technologies is another project. And you must be equipped with quality assurance and quality control and productivity benchmarks. How fast we can do bringing this technology is most important. And then equipment knowledge should be there. Tools and accessories we should learn. So this makes the engineering knowledge complete. Then, of course, our attitude, temperament, and commitment, because civil engineering job is a very challenging job. It is almost like a battlefront. You need to have a lot of coolness to learn the job and do it. You'll have good stress and the timelines and all that. Then you must be, above all that, you must be a leader, because where you are working, you may not have any help. You are the lone leader there, and most of the project sites are very remote. You must know that you need to develop those leadership qualities. And with all these things and using technologies, one can become a good civil engineer. In summary, I would like to say geotechnical engineering, the design is one part, and construction is another part. Construction is complete. Only design is not complete. Unlike in structures, you can release the drawing and then rest is taken by the construction side. In design for foundation engineering, you have to be all the time available, because soil is an unknown material. So design changes are required, methods have to be changed, sometimes equipment has to be changed. So unless the construction is complete, your design is not complete. The second one is you must have knowledge of technologies, equipment, and methods of construction. And the third one is, if foundation, most important thing is foundation. If foundation is delayed, the project gets delayed, that you can be rest assured that if the foundation construction is delayed, your project will go for a 6, both in time and cost. So we have no choice but to embrace technologies if we want accelerated growth and development of our country. And I request that you spend some time learning these things. A lot of these things will be available on YouTube. Those titles and all that I introduce some names and vocabulary. You will be able to go through them in more detail. You can see the case studies of both success and failure stories to become well equipped with knowledge. Thank you, and I wish you all a very bright career. Thank you. If you have any questions, I am available.
Yes, sir. Thank you very much, sir, for sharing your words of wisdom and throwing light on the subject, the role of foundation technologies in infrastructure development of India in a best possible way. Now I request all the participants to post their queries in the chat box of Zoom and YouTube so that Manoj Kumar, President of AAC SVC Student Chapter, will read them out one after the other. Please, Manoj.
Unmute yourself, Manoj.
Thank you, Hemashri. So here are the few questions. The first one, China Bridge in Jammu Kashmir located at 359 meters high. What type of foundation and technology they have implemented on that construction, sir?
No, but normally you have a very good river-bound soils will be normally good. Even if you have done piling there, it's not a big issue. I am, because I am not involved in the project. I don't have the direct knowledge. But access being very tough. Probably whatever type of foundation you do, taking the equipment and all that is extremely difficult. I really do not have that first-hand knowledge about that. What type of foundation? But I knew that it took very long time.
Yes, sir. How can we reduce soil investigation cost, which is reliable?
Can you say again?
How can we reduce soil investigation cost, which is reliable?
Want to reduce the soil investigation cost?
Sir?
Do you want to reduce the soil investigation cost?
Yes, sir. Yes, sir. Reduce.
No. I think see, soil investigation. If you look at the percentage, as I mentioned to you, the foundation cost itself is 1 to 5% of the entire project cost. Soil investigation will not be even 1% of the foundation cost. So it is very, very small, and many times the clients make the mistake of taking some borewell contractor and ask him to do the soil investigation. And there are many companies in India who are only just asking some borewell contractor to bring samples to their laboratory and they test it and write report, which is a very, very unfortunately bad practice. Unless the geotechnical engineer goes to the site, you have to actually increase the cost of soil investigation if you want to have a good soil report. If you reduce the cost of soil investigation, people will try to cut corners, and they actually don't do soil investigation, but they produce a report, and that will be very dangerous. Ultimately, the cost of project will be very high.
So thank you, sir. And here is the final one, sir. How to choose our career path to have exposure to such advanced technologies in geotechnical fields, sir?
Yeah, I think the best is that some of you can, as students, in fact, in Deep Foundation Institute, we are trying to promote. We have got we have almost got 350 professors from across the country, and we have started a kind of student outreach. And in the student outreach, you can become members. And I think I asked our director operations to send some invitation to Professor Yeswar Reddy Garu. And once they become IIT Gandhinagar is taking the lead. We have formed a committee for the student outreach, and we are approaching various colleges. One of our important initiative is to organize industry internship programs, so that students can take their choice subject within civil engineering. Suppose somebody is interested in structures, they can go to that industry and get some month exposure, and they can do a small project, things like that. We are trying to do it. That is one way of helping you to do that. there is a paper from Monash University where they have done an experiment like this, how to expose students to technologies. They have used a camera, video camera, for the entire length of the project. They have taken important stages of projects. They have taken videos, and then before that video and after the video is exposed to the student, they try to understand their knowledge of understanding of the various construction processes, and they found that it was very beneficial to the students. I think some of these things we should introduce, and the faculty, academics and industry in India must work together to develop these things, because most of the construction companies will welcome you if faculty and industry come closer and try to help the students learn these industry practices. Yeah, did I answer your question, or
Yes, sir. Yes, sir. Answered, sir.
we
Answered,
have
sir.
a
Thank you,
Deep
sir. Thank you
Foundation,
very much.
Deep Foundation Institute. We have got a free student membership. Those who are doing MTech in geotechnical engineering, we are giving them a free membership. They can join, they can participate in our webinars, they can interact in our conferences, publish papers, student papers, so that you will be knowing more people in the industry, and you can contact them for your career selection.
Okay, sir.
Yep.
Thank you, sir.
Thank you.
Yes, sir. Thank you very much, sir, for assisting and clearing all the doubts. And thank you, Manoj, for volunteering the question answer sessions. Now I request Yashashwini, corresponding secretary of ASC SVC student chapter, to deliver vote of thanks.
As we have come to close this event, it is my pleasure to deliver a vote of thanks on behalf of our team who have helped to make this event a magnificent success. I wish to thank our guest speaker, Dr. K.S. Ramakrishna sir, for gracing today's webinar and sparing his valuable time in spite of this pandemic situation. I also thank Dr. O. Ishwareddy sir, faculty advisor of ASC SVC student chapter, and express our profound gratitude to our principal and management for their continuous moral support and guidance. I'd like to thank the coordinator, office bearers of ASC SVC student chapter, faculty and students of civil engineering, thanking everyone for participating in this event and helped to make this event very successful. Thank you.
Thank you, Ramakrishna sir.
Thank you.
Bye, sir.
Thanks, Andy. Thank you very much. Thank you all, students. Bye-bye.
Bye.
Thank you, sir.
Thank you, Purushottam garu. Thank you,
Yes,
Professor
sir.
garu.
Yes, sir. Thank you.
Shall I leave now?
Thank you, sir.
Yeah, sir.
Yes.
Thank you. Bye-bye. Okay, sir.
Bye.